Good afternoon, everyone. Thank you again. Allow me to introduce myself. My name is Aditya Patwari. I'm a second-year full-time MBA student at Anderson and part of the Energy and Cleantech Association. And we're very honored to have this conference, and we're glad that everyone could attend, and we hope you've had a great time so far. This panel, of course, is tech-enhanced sustainability, a focus on AI, virtual technology, and smart cities of the future. So I would like to introduce the moderator for this session, Trelynd Bradley, who's to my extreme left. He is the Deputy Director of Innovation and Emerging Technologies at the California Governor's Office for Business and Economic Development, or GO-Biz. And in this role, he leads efforts to maintain and advance California's role as a leader in cutting-edge sectors such as AI, quantum fusion, space, and others. And prior to GO-Biz, he worked as a policy analyst, and he has a lot of experience in that field. I'll now hand it over to Trelynd, who can introduce or allow the rest of the panel to introduce themselves. Thank you.
Great, thank you. And thank you everyone for joining us after lunch. I know the panels right after lunch can be a little intense, like we just had all this amazing sweet green, but trust me, this is a very enlightening and timely topic. So my name is Trey Bradley. I'm Deputy Director of Innovation and Emerging Technologies. That's a very long title. I'm not going to say the whole thing. But basically, I work at the state level on the economic competitiveness of California across an array of sectors, primarily at those sectors that are kind of at the technology readiness scale and commercialization level, but then also those that are often VC heavy, but also thinking about how we ensure that all regions of California are able to benefit from these new and emerging technologies. We have an amazing panel, a group of folks across a spectrum of backgrounds here to talk a little bit about what they're all in doing. And I think one parallel you'll see across this is we are truly in a period, I kind of say it's like the great acceleration, but we have an array of sectors right now in our economy, 4 or 5 sectors, of which AI is one, which we have had the largest compound annual growth rates in U.S. economic history. Space is another, right? And that's just to put that in perspective, the potential market value within these sectors is enormous over the next couple of decades. So we're really in a period of great acceleration, a lot of venture capital, a lot of opportunity, and a lot of new innovation startups. And with that, I'm going to go ahead and pass it over to my panelists, and I'll go right along the line. So Ketav, maybe introductions to you.
Sorry, just quick note before that. Like we did in the main session in Crown, we do have a Slido QR code at the bottom right of the screen. So please use that to submit any questions, and there'll be a Q&A session at the end, which we'll try to address some of those questions. All right, thank you. Back to you.
Thank you, Trey. Ketav Mehta. I'm a partner at Motus Ventures and Spark Studios. This is a climate tech VC fund and venture studio. We specialize in investing in early stage climate technologies coming out of universities. We've done this many times now at UCLA, Caltech, Stanford, Berkeley, and a few other such universities. Deeply involved at UCLA, used to co-lead UCLA's Climate Tech Accelerator till a year or so ago, and also a lecturer at Anderson, offering a course on climate tech entrepreneurship in next quarter. Hoping to see some of you in that course. Before that, I've spent almost a decade at McKinsey, leading a lot of our work in sustainability, climate, and clean tech.
Great, thank you. My name is Kevin Barker. I'm the manager for energy environmental policy at SoCalGas. And I apologize, I'm a bit embarrassed. I should have known coming to a UC campus not to wear a tie and be a little too stuffy. So at SoCalGas, we're the largest gas utility, only utility in the United States. We serve about 20 million people. We own and operate our infrastructure, which is about 100,000 miles of pipeline. That's both transmission and distribution. We receive a lot of our gas from out of state through interstate pipelines. Let's see, we own and operate compressor stations, underground gas storage facilities. So that's a little bit about us. We serve pretty much the whole bottom half. If you think about Fresno as kind of the midway point in California, we split Fresno between us and PG&E, and then we have a sister utility that south, and then we have a sister utility SDG&E that covers gas for the San Diego County area. I've been with SoCalGas for about 4 years now in the policy space. And then prior to that, worked in state government at the California Energy Commission. You all heard from the current chair. I was the chief of staff for the former chair for about 8 years, and then also ran their fuels and transportation program, which focused on battery electric vehicle charging and hydrogen refueling stations.
Hi, I'm Anniina Autero from the city of Tampere, Finland. I had the good fortune to be here today with you guys. I came on Sunday. I'm leaving tonight, but I'm trying my best to get rid of the jet lag. Thanks so much for the invitation. I'm excited about this panel and the possibility to discuss with these wonderful experts and gentlemen here. I'm in charge of the development projects in the city of Tampere. So we do smart city projects. We are internationally recognized as one of the smartest cities in the world. We do work with the Dubai, UAE, Singapore, Barcelona. We've got some recognitions from Barcelona Smart City World Congresses on our resilience and smart city solutions related to IoT platform, how we utilize data in the cities and decision making and in planning, and how do we participate the residents and the visitors to the work. So I'm going to be speaking about some of the solutions that we have been working on for a couple of years around resilience and sustainability, how we are utilizing these technology solutions in the metaverse. I have a background also in the academia, so I've been working most of my life also for the academia. So I'm also supervising some PhD students in Tampere University. I've been doing my PhD partly in Stanford and also in Denver, Colorado School of Public Affairs. But let's hit on. We're excited to hear some questions from Trey.
Great. And really quick, because right now we're at 1 o'clock, I just want to see a show of hands. Today, who has engaged with artificial intelligence? Who has used AI today in some form or fashion, right? Isn't that incredible? It's 1 o'clock, and almost the entire room had their hands up, right? I think that...
the Q&A thing has an artificial intelligence advantage.
Yeah, all right. Oh, the Q&A, right? So, Just to put that in perspective, like in the same way the internet, right? We're talking about transformational technologies and how people engage with them and how much they're in use. I just think it just puts into light of how transformational this technology is, but how much is making an impact across not only industry and our public life, but also our institutions and our government agencies and our communities. So with that, I do want to drive into questions. And so, you are our guest here from Finland. So tell us a little bit about your city, how you were approaching things as a smart city. You mentioned some things like metaverse. Some other things. Would love to hear about the city also, and what are some of the strategic initiatives you are looking for to implement in a smart city setting?
Yeah, sure. Thank you. Thanks for the question. So Tampere is a relatively small-sized city, globally wide, but in Finland it's the third biggest city. We have 255,000 people, and we are a city that is growing, so we're getting more people than losing. As we've heard today, most of the people will be living in cities by 2030, so that's the same with us. But we are having the season, so we are having a long winter season and we are having a long summer season as well. So we need to prepare ourselves for the changing seasons all the time, and we need to utilize the smart solutions to work for the well-being of the people. And sustainability is for sure sort of the ground base for that work. We have been chosen as the happiest country in the world for 7 times in a row. If you ask a Finn about this, we always get embarrassed. But that just makes us to aspire more, that we want to serve the people and we want them to be happy and enjoy their living. So Tampere is heavily technology-oriented, with the heavy technology-oriented way the public services for the residents. So the metaverse vision that we did for 2040 is quite ambitious, that we are also building the physical environments of the city, but we are also doing that in the digital world. And that means that we are utilizing the sensors in the city. We are collecting data of people and traffic flows, for example. I work with the resilience and security work as well. So we collect the data so that we can utilize it in the city planning, we can utilize it in decision making, and we are doing strategic work step by step, that these initiatives and the project that we do, they are strategically chosen, that there is a holistic target for the work that we are serving. And then we are utilizing AI to identify what is normal and what is not normal in our city. And we can't use the biometric identification, so we need to take that also into consideration in our work. And we utilize a lot of digital twins as a tool in the metaverse. These digital twins offers us a possibility to kind of explore the future. How will the future city look like? I will show you one example today. And then also it gives us some sort of a mirror of who do we want to become like. We are organizing, actually this is more of an ad, we are organizing a venue called Imagine the Cityverse, and it's going to be in May in Tampere, so you are all welcome to come. I can speak about that as well a bit more.
Probably for a city of your size, I've not heard many who have embarked on digital twin here, even in the US and California. It's pretty ambitious. Kevin, I did want to turn to you because I know that I always say this to everyone. You've probably driven over or driven under or over or past hundreds of pieces of utility infrastructure in your single day. SoCalGas is obviously an enormous entity. You shared, splitting of the Fresno all the way down to this, to our part of the state. And background question for you: can you tell us a little bit about SoCalGas, where you all are as a gas utility, and what you are doing to prepare for the world of tomorrow?
Sounds great. So we've been around for about 150 years, so we've got a ton of experience in moving gaseous molecules. Our mission right now is to provide safe, reliable, and affordable energy with a gear towards tomorrow. And so one of the things that we're thinking of, and we have to continue to think of, is the political and the real economic environment in which we live, which is we're unfortunately moving a bit away towards affordable energy. So a lot of things are getting more expensive, and so for us, really top of mind is to anchor into the affordability of the energy to allow us to do the cool cutting edge technologies of tomorrow. One thing that we're looking at is doubling down on how we utilize our assets, and so this is where AI potentially could take place. So we actually have essentially stock traders, but what they're doing is they're buying and selling gas molecules. They want to buy as cheap as they can, so that way we can sell to our customers as cheap as possible. And so we have huge storage facilities. We have about 120 BCF, so that's billion cubic feet. To put that into perspective, it's roughly equivalent to 1.2 million Tesla Powerwalls if they use one sort of full cycle. So if you think about a Tesla Powerwall that can kind of fit in your home, we have in California about 12 million homes. It's 1.2 billion Tesla. Sorry, it's the billion. So if you think about the scale of the energy source that we have, it's 100 times that of having a Tesla Powerwall in your home. And so being able to utilize AI services to get the best economic value of when we kind of buy and sell gaseous molecules, we'll be able to provide that really affordable energy that can help with a lot of the other new cutting-edge technologies that we want to see in California.
Great, Ketav. I see you writing there. I'm like, you've got a lot moving through your mind. Maybe here, give a little bit of background on yourself. What are you also seeing at the cutting edge in terms of VC, in terms of new startups in this space, as we're talking about a little bit, we're kind of really focused on the local level, maybe smart cities, AI, and Cleantech?
So happy to talk about this, and we focus a lot on sustainability and clean tech, and we also have a theme of smart cities, or specifically solutions that are within the sustainability climate tech domain that help a city in becoming smarter. We typically look at this in 6 different buckets. First bucket is transportation. So this is your electric transportation. This is traffic management. This is also EV charging. In some other parts of the world, this will also be battery swapping stations. How can you make the transport infrastructure a lot more efficient and cleaner? Second thing that is a focus is also waste. Waste is a big part of the problem. Some of the largest methane emissions that happen in the world today are actually from these landfills. Some of these landfill emissions are as large as leaks happening from oil and gas plants. So focusing on that is important. Here we look at technologies that can help us in doing waste segregation, recycling technologies. Some companies we spoke with, one of the most challenging things that I have found, and also many of us have found, is the 2 or 3 dustbins that we see. It's always a brain teaser. What will this go in here? Do I have to empty the food? Is this compostable, not compostable? I used to do that very rigorously till one day I found that the people were just mixing the 3 trash cans and taking it all together. Right. So there are technologies that we've seen that using image processing, using AI can, in a moving stream of trash, segregate all the waste into the different types of components. So that's some of the technologies that we are focusing on. We also focus on smart recycling technologies, technologies that can extract precious minerals, trace minerals from wastewater, from organic wastewater. Technologies that can make synthetic methane from organic waste. That's being developed at UCLA here. The third thing is of focus for us is air quality. Air quality monitors, air quality sensors, getting the right alerts to the right people at the right time. Another technology being developed by Caltech and UCLA is a very small chip, the size of a SIM card, which people can carry on their phones and can immediately detect methane levels and CO2 levels and other pollutants in the atmosphere around them. Heating and cooling is a big theme, especially as the world gets warmer. Many innovations as simple as, can we make reflective paints? It's very difficult and also very expensive to air condition all the spaces. So can we at least have a delta of 10 degrees, 15 degrees from outside air to inside air? If outside it's 100 degrees, can we at least have 80 degrees or 90 degrees inside? That is still more livable than outside. There's of course energy and electrification. And the final theme is low carbon construction. Lot of startups that are making concrete that is as affordable as regular concrete, but 50 to 100% low emission content. So some of these areas, we are increasingly interested in these areas and happy to talk about specific examples, specific startups as we move ahead.
Yeah, I actually will get into that, and I'm going to drift a little bit from the questions here because I do want to follow up on some of this, and then I have one for each of you too. But a little bit onto what you were just saying, and all of those verticals, right now I would say, I'm sure this is the case, but we are in a very different financing landscape than we were 2 years ago. And I think there's 2 things that have probably dramatically altered that. One of that is that, even though we have the Inflation Reduction Act, right, we have these policies in place that encourage it. We have a new administration which has different ideas about different things. And then, of course, we also have markets out in the VC world and the private sector who maybe want a little bit more assurity on return on investment, or surety or guarantee that products will come to life. So maybe in each of those verticals, what have you seen change in the last year? What has gotten more attention? Is it cement, or is it low carbon materials? What has gotten more attention the last year? And what has been asked of investors across all of these spaces?
That's a great question, Trey. I think the overall underlying theme across all of these sectors is the movement from green premiums to actually green discounts. Typically the assumption 2 years back, 3 years back was, okay, customers and cities and consumers will be willing to pay a premium for my product if it's sustainable and green. And the question was, okay, how much is it? $100, $200, $1,000. Now it's all about, it needs to be sustainable or slightly more sustainable than what exists, but it needs to be at a discount than what exists. Even if there is a premium, it needs to be a negligible or a very small premium. So that's the overall theme that is guiding which sectors are gaining more traction and gaining less traction. So to give you an example, as recent as maybe a year and a half back, Frontier, which is a group of Mehta, McKinsey, Stripe, they bought carbon credits for $1,000 a ton. The typical price for this in the market, like you can get nature-based credits for $25, $20, engineered credits for $100. There were deals that were happening at $1,000, $1,500, $800 a ton. In the last 1 year, all those deals have dried down. Right? The most expensive deals that you're seeing are maybe at $100, $150, $200, $250 a ton, which are biochar deals. So that's what's happening. Now, tactically, what are the areas that are continuing to get traction out of all of these areas? We are definitely seeing waste become very important. Air quality become very important, especially after some of the wildfires that we saw here. Heating and cooling is becoming important because people are realizing that this will be needed as climate gets worse before it gets better. We've seen electric vehicles take a little bit of a hit. Electric vehicles, batteries, EV chargers, a lot of startups are struggling to raise funding in that space. We've seen hydrogen startups also get impacted, green hydrogen startups. But other technologies like synthetic methane and others, they've been picking up. And on construction, what we are seeing is there used to be exotic construction materials at 5x the cost of traditional concrete that were popular. But now I think it's at the same cost, but also having slightly lower carbon that is getting traction.
If I jump for a second. Yeah, I think resources and technologies that have sort of bipartisan support are ones that would continue through. And so, I think, about energy efficiency, and this kind of gets to the green discount. If you can, purchase a piece of equipment, whether it's, an appliance or a car that is much more efficient, and let's say the cost premium isn't better, you have buy-in from both sides. It's greener and it's cheaper. And then, yes, I think hydrogen may kind of take a hit, but I think you can have support on both sides. Now, how green the hydrogen is and what the CI content may change depending on kind of what aisle you sit. But the idea of getting economies of scale and demand for a product like that, and then to decarbonize it, is something that you may have support of. You had the U.S. Chamber of Commerce write a letter to the Department of Treasury supporting 45V and saying we need it as is. Now, maybe you can make tweaks along the way, but we don't want the new administration to take down what the previous administration put out as guidance documents. And then the other one, and I think there's probably great promise here in California, as well as elsewhere, is direct air capture or carbon capture of any source, but especially direct air capture. We have already emitted a lot of carbon into the atmosphere, and so support around direct air capture is something that I think a lot of folks can get around. Need point source also, but direct air capture is also another one.
Kevin, actually, can you share a little bit about because I think there's two parts there. One of them is hydrogen, and then the second one is the direct air capture. Can you share a little bit about SoCalGas? I also just want to mention, direct air capture often requires gas-like infrastructure to facilitate pipelines that are regulated at the federal level, right? And then, of course, hydrogen. We have Arches in California, which is, our hydrogen hub, Department of Energy proposal that is, a multi-year effort. So can we a little bit talk about SoCalGas, both your role in hydrogen and direct air capture?
Yeah, so it's we're looking at. I'll start with hydrogen. We're looking at a couple different phases. Some of it is research and development, and so the research and development is can we follow in the footsteps of some of our Europeans in which they have been able to inject hydrogen into the existing natural gas pipeline. There have been a number of studies on that, and think that there's essentially a threshold when you blend hydrogen and natural gas, at which point it no longer acts as the gas no longer acts as natural gas and starts to act like hydrogen. And that there's some different studies, but that's somewhere around 30%. And so if you have, let's say, a standard or a threshold far below that, and it's safe to deliver through pipelines without things like embrittlement and other things, depending on the types of pipes, then you could start to decarbonize the existing end uses of gas through the existing infrastructure that's already been capitalized and underground, so it's resilient and reliable. Is that one possibility? I think the big piece there, and this is sort of a critique of that, is that the energy content of hydrogen is less so than natural gas. And so let's say if you blend 20% hydrogen into the existing pipeline, you may get 7% or so GHG reductions. But what that does is when you have a system as large as ours that's serving 20 million people, if you blend 20% in hydrogen, you're creating that demand that then you can get economies of scale to really move the very, very low carbon to zero carbon hydrogen. And so the creation of that demand really kind of helps get us to the lower cost hydrogen. The other one that we're looking at is direct pipelines. So pipelines that are created for and designed and dedicated to hydrogen. And what our Angeles Link is looking at is open access, non-discriminatory pipeline, where you can have producers of hydrogen access the pipeline to deliver to customers that they, on the other end of the pipeline, that they have contracts with. And so our goal is to be just the infrastructure and the highway, if you will, of delivering the produced energy to the end use. And I don't know if that was a time signal or not. Or okay.
It's gonna get more lights.
And the goal there is really for the kind of the hard to decarbonize sectors. So things like electricity production. Now you may say, well, that's not hard to decarbonize. We have wind, solar, offshore wind, geothermal. But the actual blending and the integration of the balancing of demand and supply is something that you can get out of batteries, but you can also get out of clean molecules. And so the state is in their long-term planning are assuming that there are still thermal power plants that are used for dispatch and load following and regulation. The other big piece, we'll say industry is a big piece. We don't want to lose our industrial economic viability here in California. In fact, it is one of the responsibilities of the Air Resources Board to avoid what they call leakage, which is people leaving the state. It looks like it's actually GHG reductions, but we've exported our GHG reductions elsewhere. But instead, but the big focus, I think, is on the transportation sector. So these, and I'll say, yeah, folks, you can get a passenger fuel cell vehicle, but these are really looking at, like one of the previous discussions, the ports and goods movement. These are transportation vehicles that are moving constantly, that may or may not have time to go offline, or the company can't buy 2 vehicles for every 1 diesel that they replace in order to allow them to charge, but to allow that quick, low carbon, and zero NOx. So we have an air quality issue in LA, so very clean for the air. to be able to do goods movement. You can also get into things like ships, potentially aviation, and those. So I'll stop it with hydrogen. Maybe we can go right there.
That is, I mean, but it does bring up a good point. But the main point that it does bring is that the demand is going to increase no matter what, and the demand is going to increase at an insane scale. I think the latest numbers that I have, and I know that we are currently calculating what percentage of that is artificial intelligence, but the latest numbers that are something that currently data centers take up 2% of grid demand, but by 2028, I believe it is 8% or 6%. I'm either confusing one of those two. I believe it is 6% by 2028. So just in 3 short year period, just on the data center. But that includes all of things. That includes artificial intelligence. That includes cloud computing. That includes all sorts of other data and technology services that flow through data centers. But, we also, just to mention, we have all of that same thing. But even in California, right, we move 40% of all the containers that go through the United States flow through the ports of LA, Long Beach, and our other 10 ports here. So you have not only the need for hydrogen for generation, but it's kind of like I've heard the term of we need an all of the above approach, because the amount of demand that comes from the sector in technology and artificial intelligence, quantum, and the likes is going to be so high, coupled with the fact that we have to make this transition and our sectors are already here. And you mentioned the leakage with the air board. I wanted to go, in the city of Tampere, I had one quick question, because when you were talking earlier about the implementation of some of your things at the local level, including metaverse, digital twin, operating these environments, I'm curious, how has your community responded, and what has their input been on your forward thinking on using technology inside a city environment? And how do they also think about implementing these new technologies that may increase demand on energy against, your local goals for the environment as a city?
Yeah, that's a great question. Would it be possible to show you the demonstration of? So I'm going to show you the video. It's a video of our digital twin that we have just done. This is it's a fabricated model of the future. So we are now in air, and the buildings that are in white in this demonstration, they are going to be new buildings. So we just opened the doors for our brand new Nokia Arena, which is a sports arena. We built it above railway station so that people would come to the venues by train and public transportation. This area where we are now walking, we are supporting this development. This is the biggest construction project we've ever done in the city. There's going to be a deck and 7 skyscrapers. And a public space where people can walk. And the DigiTwin is a possibility to demonstrate different simulations when it's the different season, different weather, different conditions in the area. And we can also collect data out of it and bring data into it. And we did these test sessions with our residents. So this is going to be in the future, 2040. So in 15 years of time, we still have some time to go. And we collect the feedback from the residents who we are thinking that could be the possible residents of the area and could be the possible users of the area. We asked them a couple of criteria: the accessibility of the area, also including the weather, the attractiveness of the area for pedestrians. That would it be an area where they would like to spend some time with? Also, the environmental aspect of the area, including the GHG indicators that we are measuring quite imprecise. Now it's becoming to snow. And then, for sure, the sustainability aspect and also the how do people take this space in use? How do they interact with the city? How do they interact with each others? Is it playful? Do we have services offered to them? So we've done these test sessions with the residents and also visitors who come from different cities to the area. And we've got really great results. So we are actually able to use the data from our IoT platform that we can get the information of how many cars we have, how many buses we have, how many pedestrians we have, how many scoots we have in this area, and we can do estimations with the IoT platform. What will it look like when we have huge venues, for example, in this Nokia Arena? So Nokia Arena is a commercial arena where you have to have a ticket, but there's a green public space which will be white and sometimes grey in winter. It's free for everyone, so that everybody can go there and enjoy the atmosphere of the venues. So the results that we've got from this are really amazing. Now we are taking steps towards going discussions with the business owners in the area, because we are changing the city center quite a lot, and it's going to be a huge construction process for us. So we are changing also their way of doing business, and now we are negotiating with them that how can we offer them data of the people and traffic flows in the future, so that they can prepare themselves for this new time and new era. And we are also building a dialogue together with them. So there's a great possibilities to utilize data around environmental aspects, and also to participate them for the work. They highly appreciate this, and they're quite excited about this possibility to kind of have these immersive walks there. So we highly recommend this possibility to anyone who's planning big venues or building the city center. It's located between two big lakes, so it's quite narrow space, inland space. So that means that we need to build higher all the time.
This is incredible. Is there anyone who works for a city, a local agency or city or county in the room? I mean, this is something that every city and county in California should have adopted, a digital twin. In California, it's often the airports or the ports who do digital twins, but to do it across an entire city with such a multi-layered focus is absolutely incredible. I do want to, I know that we're coming up time. I know that I have quite a few questions. I do want to ask one question, multi-pronged for everyone, and anyone can answer here. But to get back, obviously, the first word in our panel is really about AI. I want to just ask, how has AI currently changed maybe your organization, how it's seeing, or how has it changed working with your stakeholders? Or what is some of the things that opportunities you see for AI in your industry and organization in the upcoming decade? I'll let anyone kind of take something on that.
Well, maybe I can start. So AI is a support for us in the work, that we can, as I mentioned, that we can sort of identify what is normal to us in people and traffic flows, meaning the cars and transportation, that we learn what is normal. And then AI supports us in that the disruptions, that what is not normal to us. It's different in Tampere and different in Los Angeles, but you need to, of course, identify what is this, the soul of the city of the transportation, that you can identify these disruptions so that you can prepare your people for that, and they share this situation awareness that what's going on in the city. So it helps and makes the people more happier when there's traffic jams, or if there's a car accident, or there's other disruptions in the city center. So it supports the daily lives of the people, and it also supports the work of different stakeholders, for example, the security people or the traffic people who need to take care of these situations. So AI is definitely a great possibility for us to do our jobs better, more efficient, and also kind of see better possibilities in the future.
You bring up a great point. I thought it was funny that you brought up transportation traffic. I've spent many times at NVIDIA headquarters, and it was funny the first time we went there with the governor and all of his staff, the first people they wanted to talk to was Caltrans, which is our state transportation department. And they're like, is there a way that we can get access to all of the data associated with all of the sensors across the Caltrans system and traffic lights? I think so many applications that can happen in transportation with artificial intelligence. It's truly limitless, as they would say, the engineers. But anyone else want to answer? Maybe AI focus changing in your organization?
I think for us, in order to fully utilize what AI has, is we need more data. And so we're, I wouldn't say we're behind the electric utilities, but the need wasn't necessarily there to have super smart meters, where the electric utilities were really starting to look at time of use and being able to use demand response. You don't necessarily need that as much in gas, but we can help create a better user experience through smart meters if we have the data. We can understand sort of the customer's use patterns. And so I think for us, it can be really a customer-facing piece that adds to the experience of the customer in utilizing the gas energy and in dealing with us as well, and finding out more efficient, cost-effective ways to lower their energy bills.
Maybe I can talk about three, four AI-enabled startups or technologies that we see today replacing the traditional model of doing something. First is we have a trend of going towards AI-enabled models versus physics-based simulations. Two places where we see this. Typically, atmospheric simulations for you to predict the path of a hurricane, for you to predict the temperature or weather from 7 days to 14 days. They rely on very complex physics-based models, very computationally intensive, take a lot of time to get processed. All the players today are now trying to see if can we have give this to an AI model, like all the past hurricane data and their trajectories, give it to an AI model and let them predict the future trajectory. AI models in the recent hurricanes that happened, they've been a lot more accurate than physics-based models. That's one area. Second area is, let's talk about something like EV charging. People drive, anyone who drives EVs here? And y'all must have seen decline in the state of health of the battery after, let's say, after a period of time, especially if you're using fast charging a lot. That happens because of lithium plating that happens in the electrodes. You typically used to have physics models of how atoms, molecules will behave in the cell to predict how much fast charging is okay, should we curtail it beyond a certain point. Now you have AI models that will predict this and that will automatically tailor the current or voltage that goes into charging to ensure a longer life of the battery and ensure you can do more fast charging. And the final use case I'll talk about is AI for material discovery. This is discovering catalysts for hydrogen electrolyzers. This is discovering different solvents for carbon capture, even discovering concrete compositions. A startup, Concrete AI, that's come out of UCLA that uses AI to figure out if you want a certain load-bearing capacity, if you want to reduce emissions, if you want to reduce cost, what is an optimal concrete composition? Because concrete has 40, 50 different things, each of them with prices changing every day, each of them with different properties.
I think we have quite a few questions here, and I want to get to them. But if you have not asked a question you want to, or if you want to participate, because you can kind of vote up questions here, if you'd like to, please utilize the link here in the code. But I think one of them I have, and I think I can help address this one, but it's kind of a two-pronged. One of them is from a Climate Karen, which is a great name here. But one of them is, given how energy-hungry and water-thirsty data centers are, how will we power them without causing skyrocketing emissions and exacerbating water scarcity? There's also another question about what role do small modular nuclear reactors play in our increasing energy needs? And I know that I believe my friend Chair Hochschild, David, talked about that earlier as well. I think that the demand in data centers is highly complex. In California, we have a couple of resources that offer baseload power that other states don't have, like geothermal. We have a high interest from all of the large technology firms in our geothermal resources now in a way they never have had. We have massive proposals for data centers. But right now, our state is competing along with, I think, 11 other states are currently competing or on the short list or in it. But if you've all read about, and there was an event at the White House with Sam Altman announcing Stargate, which was a data center project in Texas. I don't think it's working out so great in Texas, so they've offered to go in. They've now widened that request for a proposal nationwide, really targeting a group of, I think, a dozen states, including ours. But the incredible demand from that alone. And I think there's another trend that we have happening in energy, which is also completely propelled by the data center development. I spent a lot of time working on fusion. There's two types of fusions. There's non-nuclear based, there's nuclear based, there's laser and magnetic fusion. California is really where, California is where the laser was invented. California is really the birthplace of fusion technology. There's been some incredible developments. I mean, our office has made some strategic investments in fusion in a company called TAE Technology, which uses non-nuclear hydrogen boron fusion. But we have firms in fusion right now in the Bay Area, including one, I believe, that just moved from Austin to California. You don't ever see news articles about that, right? Why isn't that ever on the front page? It's always the opposite direction. But anyways, they moved from Austin to the Bay Area, but they raised $1 billion in Series A as a fusion company this over in the fall. That has never been seen before. There's been a couple of breakthroughs in fusion that have happened on both ends, magnetic and laser. But we're going to need these innovative solutions, because I think even one small commercial fusion plant is equivalent to 255 floating offshore wind turbines, and we're about to put hundreds and hundreds of those off of potentially the California coast. So we need to unlock some of these innovative solutions, I think, is one piece. On the water piece is a huge challenge in California. I'm not going to get into a long-winded thing about water, because there's been a lot of made-up, fictional things said about water in California in the last month and a half, including hidden faucets somewhere in the Pacific Northwest that turn on. But we've had a couple of companies. We have a company called Nautilus, which is based in Stockton. They have a floating data center that uses recycled water on the river there in the San Joaquin, and has zero impact. As the UC and the CSU have both done multi-year studies, no impact to wildlife at all. It is a really revolutionary technology in being able to reuse water. And they're now considering a floating data center down here using seawater at the Port of Los Angeles. So we have these innovative applications, I think. Anyone else want to talk about kind of data center demand growth and maybe innovative startups you see in that space?
A lot, but let me maybe just talk about one or two interesting startups, right? So one startup is working on DC based data centers. So typically your grid power is AC, a lot of your demand is DC, and converting that leads to 10-15% losses. Not a lot, but if you look at the amount of data centers being built, it's a lot. So can you actually create DC to DC systems, right? Solar panel produces DC power. Yes. Fuel cells, some of the fuel cells produce DC power. So, that's one area where people are talking about. People are also working on coolants that are a lot more efficient in cooling the data centers and will reduce the water demand and can reduce the cooling load requirement. There's a lot of cooling technologies, desiccant based cooling technologies. So typically if you leave salt open in a moist place, salt will absorb moisture. That will also change the temperature of the area. So there are these desiccant based technologies, some that Bill Gates has also funded, which can achieve similar cooling levels at 1/3 the price of traditional HVAC technologies.
I think this question probably most geared best towards Kevin, but this is a question right here at the top is, with cities like Lancaster and City of Industry developing their own municipally owned hydrogen facilities, is this a big demand signal for green hydrogen in Southern California?
Yeah, so I recently heard about these and haven't really looked into what they actually mean. I feel like I would say that the big demand signal is federal emission reductions that, let's say, power plants have to do. The demand signal really is the ARB's scoping plan of how will we get to carbon neutrality by 2045. The big signal is cap and trade, which may be up for reauthorization, which limits the amount of emissions that industry can do. Those, and again, that's at scale. City of Lancaster and City of Industry, it's great for municipalities to want to get into this space. I think for are we the fifth largest economy? Having fourth. Okay, fourth. That's why I was looking to you. Having a state the size of California, to me, that is really the kind of driver. Is that we need to reduce our emissions, and clean molecules are a pathway, and things like arches are could present a solution.
I think this is a great one. This one is focused on Tampere. What can LA 28, because we had a great discussion on the future of LA 28. How can something like LA 28 learn from the experience that you've done as a city with digital twins to smoothly move people and masses across a city? And is there still time to implement such types of technology that you've done in your city, perhaps in LA before the big games?
Yeah, thanks for the great question from the audience. Yeah, sure. There's a lot of possibilities, and I would like to say that the number one first thing would be this shared situation awareness, so that you would have a sort of a tool to support the stakeholders, the most important planners and the resilience, sustainability, security actors who are sharing the same understanding related to data, what's going on. We did this joint situation awareness work for our Ice Hockey World Championships games that we had 2022 in our brand new Nokia Arena. We did a couple of simulation exercises with these digital twins. So in case there would be a traffic accident or a fire or even a terrorist attack. And we were lucky to do the exercise because Russia started the war just before the game started. So we had to overnight not to let them come to our country, and we couldn't get the Russian ice hockey players to come to the venue, even though they are really great in ice hockey. So we were sad about that. But so these, my message is that there's always something ongoing under the topic of resilience. There's always something coming up. So we can't control that, but we can prepare ourselves with the digital twins. We can do the simulation exercise so that we do seamless collaboration between the actors, and we share the same situation awareness. We utilize the data, and the algorithms support that work, because we can have the city full of cameras, full of sensors, but there's no such team that could have a look at those streams. We need AI to do the work for us, and it identifies these disruptions and these elements that we should pay attention to, that the machine works for us. That's one of the important angles. So there's a lot to be done, and there's great possibilities. It's going to be huge. We downsized the number of people who came to the Ice Hockey Championships games, but we still had more people coming to our city than we have residents. And economically, it was a huge thing. We actually did it twice. So it was a really big impact for us. So we like to think that these huge venues are investments also for the sustainability, that we need to do the calculation and the maths, that what is actually the return on investment for our environment, and also for the social return on investment, that we got this figure that we got 30% in public savings by using these solutions that we were working for the smart urban security and event resilience, and we generate digitwins. So it's definitely something worth doing. Yeah.
And then I know that we're coming up on time here. This one maybe for Kevin, or this one can be really for anyone, but I know that this one is something that for those of us at the state think about a lot. But what is your overall opinion on the current state of the carbon market? Do you think it's working effectively to take out GHG from the atmosphere at the current state? I will say it is very challenging. It is very challenging when you have one wildfire. Emissions from one wildfire equates to maybe hundreds of grant programs worth of emissions reduction, which is just an enormous challenge. Every time a wildfire happens, that's the first thing I think of how many California climate investment programs, GHG reductions that's worth. But I do think it is. I think you're having increasing buy-in across the world and at the subnational level that is tipping the scale. Maybe not at the speed that we need, but want to see if anyone how has any thoughts on that.
Yeah, I think with carbon emissions, you kind of have two categories, and there's the wildfires, and then there's the ones that we're really focused on, which is the anthropogenic emissions. And so I would say it is successful. So our cap and trade program, we met our 2020 goals 4 years early. Now, we had a little bit of a dip in trying to get to 2030 goals, but, it's possible when you have you have that cap, and you also have the ability that if you do go over the cap, that you can purchase allowances in order to meet that. And so it gives a long-term signal in which you can, point to investors to make your choices on how to reduce their emissions. And so that's really beneficial. I would say where it gets tricky is when you have a deadline and there's no extension. And so California, we're running up against the end of our cap and trade program in 2030 with not a clear signal. Can we get it extended? Who extends it? Is this the legislature? Is this the ARB under their existing, mandates and authority? That's where you get these crazy declines. So the carbon market's like close to the floor right now because I think of the unknown. And so if we can get long-term certainty, I think that really helps drive the market.
One thing I can share from, and this is perspective also in working with the Trump administration prior and Trump 1.0, I guess Trump 2.0 or whatever you want to call this second one, but it's transcended all three of these administrations in emissions and carbon reduction is domestic production of certain materials like critical minerals. California is the number one critical mineral producing state in the United States right now, and 5 years ago we didn't produce any of the world's, all of the rare earth supply came from China. But in the last 5 years, California now provides 15% of the global rare earth supply. The rest is China. So if you buy whatever this is, or an electric vehicle, the rare earths that power your vehicle or whatever, it's either from California or China. But those used to all come from China, and even in the early stages of rare earth operation, to be extracted here and go all on a ship all the way to China to make magnets and then come back to the United States. And how many emissions just go from just taking the same thing from within miles of where you're going to make it, and then it comes back to go into Teslas. I think there's one thing is that in some of these large macro areas where there's emissions reductions that have been achievable, I think there's huge momentum in that space too. And I think there's a lot of bipartisan support and alignment. So I see my cue over there on the far right. I know that we're running up on the hour. I want to thank you all. Thank you for bearing with us and taking the time. Appreciate everything and all of these great, fantastic questions. Of course, I think some of us will be around here if you want to speak to us. Of course, I think our contact information is also available if you want to reach out as well. And so I'll turn it back to you.
Yeah.